In this problem, we will use the normal distribution function in Excel. A manufacturer of a printer determines that the mean number of days before a cartridge runs out of ink is 75 days. So that's our mean, or mu. With a standard deviation of 6 days. Assuming a normal distribution, what is the probability that the number of days will be less than 67.5? So if the average is 75 days, and standard deviation is 6, what is the probability that the number of days will be less than 67.5? So this is 67.5, and we want this area right here. So we can use the NORM.DIST function, or normal distribution function. Our x in this case is 67.5. Our mean is 75. Standard deviation is 6. And do we want true, meaning do we want it cumulative all the way from the left of the curve, left tail, all the way to our point where x is? And the answer is yes. So I'm going to put true. And the answer is 10%. Now, with all of these normal distributions, you do want to put true. In order to find this part, this area under the curve, in order to find this area, which is the area to the right of or greater than any given x value, we're going to have to do a subtraction, and we will get to a problem like that. But for now, this is what we were interested in, this area right here. Okay, so this is the probability of x being less than 67.5. And because the normal distribution is a continuous distribution, or a normal random variable is a continuous random variable, the probability of it being exactly equal to a number is very, very, very small, which we can assume to be 0. And so really the probability of x being less than 67.5, or x being less than or equal to 67.5 are both the same, which is almost 10-11%. Now, what is the probability of more than 88? Well, here is our distribution for that's a different problem. Again, the mean is 75 days, standard deviation is 6, and we want more than 88. Now 88 is to the right of 75, so more than 88 would be this area right here. So to find that with the normal distribution, we say equals. Now here's where this area right here to the left of 88, we know we can find that by this function, equals NORM.DIST 88, 75 is the mean, standard deviation is 6, and I can say true because I want the cumulative distribution for all the way from negative infinity to this point right here, to this point. So this right here is the probability that x is less than 88. X is less than 88. So to find the probability that x is greater than that, this I would have to take 1 and subtract from it this value that I computed. So this is the probability that x is greater than 88. Of course, when computing this, I could have just inserted 1 minus, like that, 1 minus over here, and in a shot I could have computed that, but I wanted to show you step by step. Okay, so then the next problem is it says Tio Anciano tequila is sold in 1 liter or 1,000 milliliter bottles. Standard deviation for the filling process is 10 milliliters. Standard deviation is 10 milliliters. If the process requires a 2% or smaller probability of overfilling, where overfilling is defined to be 990 milliliters, what must be the target mean for the process? So the mean is what we're looking for. This is the mu that we're looking for. But we do know that since we want only 2% probability of overfilling, which is defined as 990, then we want to compute this mu. Well, we have enough information that we can find on, this is on the x-axis, on the z-axis we can compute the z-value associated with 990. And to do that, we can use the NORM.S inverse function, standard normal inverse function. So what is the probability? Well, the probability of that's because I'm in formula mode. Okay, that means all of this area right here, I can use all of this area, which I know is 98% or 0.98. Why? Because I know this area right here is 2%. So I can use that knowledge and the standard normal inverse function. So norm.s inverse, and then I will put 0.98. So my z value over here is 2.054. That's the z-value that is related to or associated with 990 as the x value on the normal curve. So now I can use my knowledge of the z distribution, which says z is equal to x minus mu over sigma. Now z is 2.054 in our problem, x is 990, mu is what we're looking for, and sigma is 10. So mu can be computed as 990 minus 2.054 times 10. So I can compute that. So mu, or mean, equals equals 990 minus 2.054 times 10. So 969.5 approximately is what the mean of the process should be if we want 2% or less as or 2% or less of the bottles to have more than 990 milliliters of content, of fluid content. All right. I will continue with problems, normal distribution problems, in the next video. Thank you.